morning. I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next lecture for Unit 3rd of the subject, that is Wireless and Mobile Communication. So, the topic of today's lecture is Diversity Combining Techniques. So, there are different types of diversity techniques that we are going to discuss today, like the selection combining technique is there, threshold combining, equal gain combining, then maximum ratio, spatial, and multiplexing in MIMO system, that is multiple input, multiple output system. So, before we will begin with this diversity different types of technique, we will see what is diversity technique. So, diversity techniques are used for improving the reliability of a message signal by utilizing two or more communication channels. So, basically when we want to transmit any information over the channel, of course we require a channel, then multiple channels can also be used instead of using a common channel, because in case of common channel there is a problem of inter-symbol interference occur. So, to remove that particular situation, we can use multiple channels, that comes under diversity techniques. So, that is a more reliable option as compared to the single channel connection between the transmitter and receiver. So, multiple versions of the same signal may be transmitted and or received and combined in the receiver. So, basically the same signal means we can take a single signal that is denoted by ST over here. This is more clear from this diagram. Then it will be transferred over different channels. These are the different channels. These all channels are having their own carrier frequencies, carrier signals of the different frequencies. Then these signals are being divided into different number of signals. Different signals are there. So, these will be combined together in the receiver. So, you can see over here that these signals used for combining and it is used for equalization. So, these are the n number of signals that will be generated after passing through multiple paths. So, in the figure, different independent fading paths are shown with different CIRs. That is carrier to interference ratios, CIR, H1T to H2 HNT, and the distortion in the signal is observed due to addition of interfering signals, that is I1 to IN and white Gaussian noise. So, basically when we are going to use different channels, then in that case also multiple noise will going to affect the quality of the signal, that is Gaussian noise, white Gaussian noise will going to affect the quality of the signal. So, the strongest signal is then picked from the received signals. These signals can be further equalized and demodulated to receive the digital signal with minimum bit error rate. So, that is the introduction of diversity technique. The diversity combining is the process to extract the main transmitted signal with minimum channel effects out of many versions of the signal that is received. So, basically in case of diversity we are using different channels. Different channels are affected with different AWG and noise, that is shifted in time and frequency, whatever we are taking the domain. So, is the process to extract the main transmitted signal with the minimum channel effects, which means whatever signal we have received, we have to extract the main transmitted signal, that is given in this diagram only, that since we have divided this single signal into n number of signals, we want to extract this original information from the different received signals which will going to travel from different path, that is multipath. Now, depending upon the types of fading, because in case of multipath propagation, fading will going to affect the quality of the signal, diversity techniques have been categorized as micro diversity technique and macro diversity technique. So, these are the different diversity techniques, that is micro and macro, depending on the types of fading. So, in case of micro diversity technique, these techniques are used in small scale fading environment. Two antennas are separated by a fraction of meter. means the distance between the transmitter and receiver is quite small. It is just in terms of meters. In case of macro diversity technique, these are used in large scale fading environment. Antennas are quite far apart and not shadowed. So not shadowed means shadowing, attenuation and fading. These are the three different drawback of multipath propagation. So in case of micro diversity, the distance between the transmitter and receiver is in terms of meter, that is quite small, and it is being used in small scale fading. While this macro diversity, the distance between the transmitter and receiver is quite large and it is used for large scale fading conditions. Now, the different diversity techniques, this slide is basically showing that what are the different diversity techniques that are possible. Like first one is the space diversity. Microscopic and macroscopic diversity techniques, space separation of half of the wavelength is sufficient to obtain two uncorrelated signal. So in case of space diversity, we have to consider the condition for correlation between different signals. So it is a space separation of half of the wavelength, that is lambda by 2. The transmitter and receiver means the two users are separated by lambda by 2 distance apart, and they are sufficient to obtain two uncorrelated signals. Second one is the polarization diversity. The obstacles scatter waves differently depending on their polarization. So in this case, polarization of the signal comes into the picture. Antennas on transmit either a horizontal or a vertical polarized wave. When both the waves are transmitted simultaneously, then received signals will exhibit uncorrelated fading statistics. So in this case, fading, the antenna polarization property comes into the picture. Next one is the angle diversity. The received signals arrive at the antenna via several paths, each with a different angle of arrival. The signal component can be isolated by using the directional antenna. So this is the condition for angle diversity. Next one is the frequency diversity. In this case, the information is transmitted on more than one carrier frequency because the frequency separated by more than the coherence bandwidth of the channel will not experience the same fading. So that is the condition for frequency diversity. Next one is the time diversity. In this case, multiple version of the same signal are transmitted at different time instants. So that is the time diversity. In joint diversity, it is mentioned as the combination of time diversity, frequency diversity, angle or polarization diversity. So joint diversity means combination of the above mentioned techniques. Now in whole, we are considering 4 different types of space diversity reception or combining methods. Like first one is the selection combining, next is threshold combining, then maximal ratio combining and equal gain combining. So 4 different types of space diversity are there. So first one is the selection combining. In this case, it is the simplest technique. It is based on the principle of selecting the best signal, the largest energy or signal to noise ratio. So in the selection combining, since the signal will going to travel over different path, it will undergo multipath fading. So since these are the different path having different gain like G1, G2 and up to Gm, so m number of different you can say options are there over the between the transmitter and receiver, then it has to select whatever path is having the highest signal to noise ratio. It will going to consider that signal. So among all the signals received from the different branches, so scheme can be represented like there is a switching logic or demodulators are used at the receiver side, and this will going to generate the output. So this is the diagram for selection combining diversity technique. Next one is the threshold. Now, threshold combining is a special form of selection diversity that is less expensive to implement. So basically, we are not using any very high cost equipments are not required. It is only being cost effective. So here a limited number of signals are considered for the extraction purpose using a threshold level. So basically what it is done, there is a threshold which has been set up so that it will going to represent, it will going to take the signal which has crossed that particular threshold value. So scanning and feedback mechanism are used over here. Why scanning is been done? Because whatever signal we have received, it has to cross a particular threshold value. When it crosses a particular threshold value, then it will be received with a better particular option. So these are the different antennas. This is a switching control system which will going to switch between these two antennas, either this one and this one. Then this will be applied to the receiver and to the short term average unit. So there is a comparator. To this comparator, there is a preset threshold value will be applied, which will going to set a particular level. Now from this particular comparator, it will going to compare that whether this received signal is crosses this particular threshold value or not. If it is crosses, then it will be considered as the better signal, otherwise it will be rejected. So that is a threshold combining condition. Next one is the equal gain combining. That is also a kind of selection combining. Now in this case, the equal gain combining is better than the selection diversity and is almost as good as maximum ratio combining. So it is better than selection diversity and maximum ratio combining, but it is less complex in terms of signal processing and feedback part. So the idea behind this technique will be clear from this figure. Now you can see that m number of different paths are there, each having their own antennas and each are having their own weights. Now these weights can be denoted by W1, W2 up to Wm. So m number of weights are there. So after these are acting as an attenuator. So after passing through these, it will be added at this co-phase and sum, then it will be considered as an output. So that is an equal gain combining technique. Next one is the maximum ratio. So equal gain is more better as compared to this one, that is a maximum ratio combining. So for noise limited systems without interference, MRC results in the best signal to noise ratio. So here all the incoming signals from all the M branches are weighted according to their individual signal voltage to noise ratio, and then these are added together. So basically, let's say there are m number of different branches are there, each are passed through their weighting functions, and then it is passed through co-phase and sum. At this particular point, the phase of each of the signal will be added together, and then it will be passed to the detector. Now the detector output will act as an feedback to this, which will going to operate these weight functions, so that the sum it will going to generate the maximum signal to noise ratio as compared to the previous case when detector is not used. So all the individual signals must be co-phased before being added. Then this requires an individual receiver circuitry and a phasing circuit for each antenna element. Then it produces an acceptable signal to noise ratio compared to the other techniques, and it has extremely good signal processing and complex hardware. So it has complex hardware because every time whatever input signal it has received, it has to be passed through co-phase, and a feedback is required. That is very time consuming, because after the here whatever we'll get, it has to be feedback to the branch weight, then it has to set the value so that the acceptable signal to noise ratio will be generated, then it will be applied to the output. So that is the maximum ratio combining technique. Next one is the spatial diversity and multiplexing in MIMO system. MIMO system is basically when there are multiple input and multiple output is used. So presently 4 different types of multi-antenna systems can be categorized based on the diversity. That is single input, single output, where no diversity is there because it will going to travel over a single channel. There is no multiple channels are used. Then single input, multiple outputs are there. That is SIMO, that will be used for the received diversity. So diversity is used only in those cases where multiple inputs or multiple outputs are connected. Now you can see over here that when multiple inputs are there, then this will be a transmit diversity. when multiple outputs are there, then that will be considered as a receive diversity, and when both are used in multiple options like multiple input and multiple output, then that is known as MIMO, which is transmit receive diversity. So the diversity is used both at the transmitter and receiver side. Now in this case, you can see this diagram, like this is multiple input single output, single input multiple output, and this is the case that is multiple input multiple output, where more than one transmitter and more than one receiver are there. In this case, single transmitter, two receivers are there. In this case, two transmitter and one receiver is there. So that is a spatial diversity technique. The comparison of channel capacities of various multi-antenna systems are there. So here we are going to calculate the capacity of the channel based on the very famous formula, that is based on the Shannon capacity formula. According to Shannon, the limit on the channel capacity is given by for the SI-SO system, that is C is equals to W log to the base 2 1 plus signal to noise ratio. So this is a very common formula that is given by Shannon, and W is nothing, it is the bandwidth of the channel, and signal to noise ratio, that whatever output signal to noise ratio you have received in terms of decibels, you have to use over here. For SIMO, the formula will be C is equals to capacity of the channel will be is equals to W log to the base 2 1 plus M into signal to noise ratio. So M is nothing, these are the multiple M number of receiving antennas are there, N number of transmit antennas are there. So in case of MISO, where there are N number of transmit antennas are there, then C will be equals to W log to the base 2 1 plus N into signal to noise ratio. Now for the case for MIMO, where there are multiple transmitters and multiple receivers are there, then the capacity of the channel will be written as W log to the base 2 1 plus M into N, where M is number of receivers, N is number of transmitters, multiplied by signal to noise ratio. So this is the very simple formula. It can be changed depending on the number of transmitters and number of receivers. Now next is introduction to MIMO, that is multiple input multiple output system. Now MIMO offers the greater spectral efficiency as compared to SI-SO, SIMO and MISO. So spectral efficiency is quite better as compared to the previous three cases. Higher data rates and greater range, increased number of users and enhanced reliability. So higher data rate means since number of transmitter has increased and number of users has increased, both are increased, so it means it will going to entertain large number of users. So larger data rate will be transmitted over the channel, and channels are divided among n number of users. It will cover greater range because since larger number of users are there, so it will all the users are not present at a same place. So these are present at different ranges, so different greater range will be covered, and it will increase the number of users definitely, because the transmitters and receivers have increased in number, and it has enhanced the reliability also. A MIMO system consists of several antenna elements plus adaptive signal processing at both the transmitter and receiver. It will going to exploit the multipath instead of mitigating it. So spatial multiplexing in MIMO is the underlying mathematical nature of spatial multiplex MIMO, where data is transmitted over a matrix rather than a vector channel. So it creates new and enormous opportunities beyond just the added diversity or array gain, benefits the spectral efficiency. So that is the introduction of MIMO. Now you can see over here in this diagram that there are two transmitters are there which are going to travel their information over separate channels. These can transmit over here also, and there are two receivers are connected in this at the receiver side. Now next is the spatially multiplexed MIMO system. In this case, there is modulator and mapping are used at this transmitter side. This is the modulator transmitter, this is the MIMO receiver, this is MIMO transmitter, this is MIMO receiver. Now in this case, the number of bits are used over here like B1 to B6 and so on. So these are modulation and mapping will be there. There are 3 antennas which are connected, which will going to radiate the energy equally in every direction, means it will going to transmit the energy like this one and to this one. Likewise, this will going to transmit the energy over here, and this will going to transmit the energy over here. So it will going to radiate the signal equally in at every antenna, at every receiver. Then there will be a signal processing is used over here, and the bits will be transmitted. Now we send multiple signals. The receiver learns the channel matrix and inverts it to separate the data. So basically, this is how the constellation diagram of the particular modulation technique is shown over here. This is multiple users are there, and this is at this particular point. This is how these are separated together. So this is the diagram of spatially multiplexed MIMO system. Now, the MIMO channel model is a matrix in mathematical form. To analyze the reception through it, we have to use eigenvectors and eigenvalues. Now, these are the transmitter, these are the transmitter antennas, these are the receiver antennas that will going to transmit the information. And here we are using the H matrix. H matrix is used to combine the input and output parameters like this. These are the input parameters that H matrix will be designed, and these are the different parameters related to the receiver side. Like this is related to the weight functions plus noise that will going to affect the signal at the channel. Now the approximated value of this particular B1, B2, B3 parameter is considered, and then we can calculate this through H inverse matrix. So H is the complex channel matrix. So this is about the spatial MIMO. So in today's lecture, we have discussed about different combining techniques, that is spatial combining technique, different diversity techniques, where between the transmitter and receiver the information will going to travel over different channels. So thank you.